what you should have noticed there in that section was we talked about reference triangles, right? You heard me talk about the right triangles that are references. Okay, this is going to be true for many different trig ratios because you can find angles that are coterminals, correct? So if I gave you an angle whose terminal side is in quadrant 1, so again, here's our example, quadrant 1 here. This angle right here is the angle that I would be using to evaluate my trig ratios. Okay, but what happens if I gave you an angle in quadrant 2? If you had an angle that ended in quadrant 2, when I drew in my reference triangle, my right triangle here, the angle that I'm measuring is no longer this angle. It's now this reference triangle. So how would I find the measure of this reference triangle if we're dealing in quadrant 2? Okay, so let's take a look at that. An angle in quadrant 2. And I'll actually select an angle. We'll take a look at this. Okay, so if this angle is, let's say, 100 degrees, and I wanted to find the reference angle. So again, I draw my right triangle, vertical line to the x-axis. So here is the angle, what's called a reference angle. Often a reference angle is going to be designated with, so a reference angle is usually going to be designated theta prime. This little apostrophe represents the reference angle. So you're looking at theta prime. Okay, in order for me to find theta prime, if my angle falls in, or the terminal side lies in quadrant 2, is I would take my full rotation to the end of quadrant 2 and then work my way back, and that's going to be what gives what's left for this reference angle. So what would that be in terms of degrees? Okay, so if I took 100 degrees, I would go to 180 degrees, and then I'd subtract my original angle, and that's going to leave me with my reference angle, theta prime. Okay? Now, if we were finding it in radians, so how would this convert into radians? 180 degrees is how many radians? Pi. Subtract my given angle, and I'd be left with my reference angle called theta prime. Okay. So let's try one in radians, or actually let's try an example of each of these in quadrant 2. Okay. So see if you can find the reference angle for 120 degrees. Okay, and then we'll also look at 5 pi over 7. If we sketch what we're looking at here, so again, 120 degrees is past 90. So if you look at this as 120, how much further is this angle? Again, here is your reference angle, theta prime. You create that by drawing in the reference right triangle here. So this angle can be found by doing what? Taking 180, then working our way back up. So 180 minus 120 leaves us with 60 degrees. So the reference angle for this first example would be 60 degrees, correct? It's 180 minus 120. Okay, for angles that are measured in radians, it may be easier to visually solve this in the same way that finding slopes using the rise over the run of a slope is easier. because the first thing that you would do, or the first thing you could do, is you could divide your rotation to pi in terms of whatever the fraction of your denominator is. And this is how I recommended you sketch these angles anyway. So from 0, or up through 1 full pi, since we're dealing in sevenths, I need to divide this into 1, 2, 3, 4, 5, 6, 7 equal units, right? Again, it's just a hand sketch of that. And if you wanted to sketch this angle, so I'll sketch it in purple here. We have our initial side, and then we rotate through 5 of those 7, right? So here's 1 pi over 7, 2 pi over 7, 3 pi over 7, 4 pi over 7, 5 pi over 7. Okay, so this from here to here represents 5 pi over 7. So how much more rotation does it take to go back down to a total of pi? Here is your reference angle. And that reference angle is going to be what? 2 more rotations, right? So the reference angle is 2/7 pi. Okay, now if you solve this mathematically, you could take pi minus the original angle, 5 pi over 7, and solve it. Pi is 7/7. If you subtract that, you get 2 pi over 7. Okay, so you could solve it mathematically or visually. I would recommend you try visually. I think it's an easier way to approach it. Okay. All right, let me talk about reference angles in quadrants 3 and 4 really quickly. All right, so here's a reference angle in quadrant 3. Okay, so if you look at the full angle, rotates here. The reference angle is formed by this vertical line to the x-axis to create your triangle. So here's our reference angle. So what would we do to find this reference angle? We take our whole angle, and we do what with it? If we know that this much of it from here to here is 180 degrees, we could subtract 180 from that, and we'd be left with our reference angle. So in degrees, you're going to take your original angle minus 180, and then that is the total sum. In radians, you simply take and replace the 180 with its equivalent in terms of radians, which is pi, and that's going to be your reference angle. Okay, and then finally, if you have an angle whose terminal side falls in quadrant 4, so that's your original angle, your vertical line from the ending side to create your reference triangle. That gives you your reference angle at the origin. Hey, what would you be finding here in quadrant 4? How would you calculate this reference angle? If you take this full rotation all the way to 360 degrees and you subtract the given angle, you'll be left with your reference angle. Again, this is in radians, or I'm sorry, in degrees. And then in radians, once again, just replace 360 with its equivalent in radians, which is 2 pi, minus the original angle, and that's going to leave you with your reference angle. All right, so see if you can find, I'm going to give you just a couple problems, or a couple angle measures. Okay, so find your reference angle for these two angles. Find for 5 pi over 3 and for Right, if you think of 5 pi over 3, that means you're going to divide this 180 degrees. So 180 degrees, just divide it into thirds. So here's 1, 2, 3. But we have to go beyond this, so we need to divide this into the remaining portion into thirds as well. And so if you count this through to see what your angle looks like, here's your initial side. You count 1, 2, 3, 4, 5 pi over 3. So here's your full rotation. In order to be left with, again, your reference triangle and this reference angle. Your reference angle can be found by doing how many more pi over 3s? It just needs 1 pi over 3 left. So pi over 3 would be your reference angle. If you calculated it as 2 pi minus the given angle, 5 pi over 3, 2 pi is equivalent to 6 thirds. 6 thirds minus 5 thirds is 1 third, and you'd still calculate the same way. Okay. I'm going to actually change this to another radian measurement. Let's look at 17 pi over 12. Hey, if you haven't, I want you to see if you can try solving for b on your own. That's about as complicated as it gets. A fraction that's not an easy fraction to work with is a little more complex. See if you can figure out what would be the reference angle for this. Okay, so again, here we're going to oops. If we start by taking pi, 1 pi, and we split it into twelfths. So we're going to have 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6 more. So that gives us a total of 12. Okay, but we need to extend beyond that. So I'm going to show the twelfths in the rest of the other half of that circle. So 1, 2, 3, 4, 5, 6, and then 7, 8, 9, 10, 11, 12. So we come back to our rotation. So what I've done here, just with these markings, is broken this into twelfths. And so each one of those marks represents 1/12. So I need to mark off 17 of those. So as I start talking through, I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So it passes all the way to here. Okay, so this rotation from here through is 17 pi over 12. When I draw in my reference triangle, it's just a vertical line from the ending side, that terminal side, to the x-axis. And my reference angle is that angle formed at the origin. Okay, so my theta prime can be solved by, remember, we count backwards. How many to get from here back to this 180 degrees or pi radians, and if you count, you get 1, 2, 3, 4, 5 pi over 7. Or I'm sorry, 5 pi over 12 will get us back to this region, and that's this total angle measure, right? You can count it from here, 1, 2, 3, 4, 5 twelfths pi is your solution. Does everybody see what I did by counting those? Okay, if you can't count, so again, it's just like the slope, rise over run. If you don't see how you can count it, you simply need to find which quadrant the terminal side lies in. Use the calculation. So this is quadrant 3. We're going to take the given angle, which is 17 pi over 12, and we're going to subtract pi from that. Pi is how many twelfths? 1 pi is how many twelfths? 12. So 17 pi over 12 minus 12 pi over 12 gives you 5 pi over 12. Okay, so you either count them or you calculate them. You have to kind of choose whichever works for you.